My name is Bertus. I had a namesake in the Zoom as well, and I'm from the Biophysics Research Group, as Prof. has told you. So my talk is titled "How and Why to Learn Programming for Data Analysis." So let's start with the why. Why would you want to learn to program? One reason is automation. So doing data analysis using programming allows you to automate every step of the process, and you can in fact, if you want to, automate everything from the raw data to the final published publishable figure, or even the whole paper if you really want to. People have done things like that. So, and that can really save time if you are doing the same kind of thing over and over again. Another one is reproducibility. So we all know that science has to be reproducible for it to be good science. Doing something in the form of code just helps. It makes it a lot more formal and a lot more structured and easier to reproduce. However, I'm sure that anyone who has tried any kind of science at all has spent a lot of time, maybe even weeks or months, just trying to reproduce someone else's results. But writing code can be better than reproducible. It can be actually reusable, which means you can share your code with someone else and they can directly reuse it. And that makes it so much easier to reproduce your results, and then of course to go on and do their own science. So I would say reusability is an even better thing than reproducibility. Another one is accuracy. Now, of course, when you write code, you still make mistakes, but once you have a piece of code that you know is working properly and is mistake-free, you can run that over and over again, and you will know that your analysis is correct. So that's another reason why writing code is better than doing things by hand, maybe, is the accuracy. Another one is versatility. So there are many things that you can do in code that you can also do with pre-existing software like Excel or Origin or plotting software of some kind. But with these things, you often end up having not that much functionality, or there is a certain level of functionality, and if you need more than that, there's no way to go. Whereas with your own code, you have endless possible functionality, and it's a lot more versatile because you can tailor it exactly to what you want to do. Then, of course, there's just the scope of what you can do. So once your data or your analysis gets large or complex enough, there really is no way to do it other than with code. And I think especially here in FAWI, there's actually a lot of things like that, even bigger data than I even work with all of this genomics and all of that stuff. And then lastly, and I think this should not be overlooked, is maybe you are not going to primarily be writing code. Maybe you are just reading someone else's code, or you just want to tweak something. So you have a piece of code, you can run it. Someone else has written it, but you just need to tweak it, or you just want to be able to understand what someone else is doing. And especially in science, we often collaborate, and often one person is doing the coding and someone else is doing something else, but you just want to know what's going on. And for this purpose, it can also be worthwhile just learning the basics, just so you can understand what other people are doing, even if you're not yourself going to be spending a lot of time writing code. So what are some examples of things that you can do? So I'm not a biologist, so I had to kind of look this up and talk to some other people. But one example is the mining of genomic data. And I know this happens, there's a lot of this that happens at FAWI. So you all probably know more than me about that. A big one is, of course, statistics of any kind. It is very useful to do that in code. This includes things like modeling, hypothesis testing, analysis of variance, and visualization. And this one, I think, especially it can be very powerful to use code just to make nice visualizations of data. And then some other ones that I found is image analysis, for example, in microscopy, and I know there's all kinds of other things. People can take photos of a plant and then do machine learning to figure out if it's what disease it has, or some, I think there's at UP some research like that, if I'm not mistaken. And then network and systems biology as well can be very, very interesting from a computational point of view. These are just some examples of nice looking plots that were made with Python, specifically with the Seaborn package. And then I have another example. So this is a graph that I made for a review paper. So it wasn't actually, there was not any real data analysis going on here. I just took some values straight from other papers and I just wanted to present it in a visual way. But I still used Python programming to make the graph. And I think that way of making figures is because it's so flexible and you can do anything you like. It's really a very, very useful thing to be able to do. So that was the question of why. So the next question is probably what language am I going to learn if I want to start programming? And here the first thing I want to say is learning how to program is a lot more important than learning any specific language. So instead of thinking, oh, I have to learn R or I have to learn Python or whatever, think I have to learn how to program, because if you can program in one language, it's very easy to learn another one, because the basic principles are basically the same across most programming languages. So, and those principles are the things that you actually need to learn and to know. Languages there are many languages, and professional programmers often use 10 different languages for different purposes, but the principles behind it is the same. And worry about those. Don't worry too much about learning one specific language. That being said, my recommendations, personally, I use Python, and another recommendation would be R. So Python is a very general purpose language. You can do anything in it. You can even write a computer game. You can do data analysis. You can make a website. Anything you like. So it's very general purpose. R is a bit more focused on, or it is specifically focused on statistics, although there are, as far as I know, a bunch of packages that allow you to do all kinds of things, including, for example, also using it to make websites. But R is a very good language, I think, for statistics and so on. It can be better than Python. I know that in biology, a lot of people specifically use R in genetics and that kind of thing. So if you will know if that is the one you need to learn. Personally, I don't actually know it, but I know it's a good language, and it's also beginner friendly, both of these languages. Another thing I want to mention here is learning how to use the Linux shell can also be very useful, and depending on what you do, it might even be kind of essential. So especially if you're going to be working on a server or on a cluster of some kind, knowing the Linux shell is very useful. And it is a bit like learning a programming language, because technically it is actually a programming language. You can write entire codes in it if you want to. So that's also something that can be very useful to know. So how do you learn to program? I think this is a case where it is something that you can very easily teach yourself, and it can be very it doesn't have to be too hard. So what I would suggest is start with a tutorial. There are a lot of beginner tutorials on the Python website, python.org. There is a basic Python tutorial which doesn't assume any prior programming knowledge. I don't know R, but I found on the R website this book called R for Beginners, which is also aimed at beginners, and it's kind of from a statistics perspective. So it's probably also, it seems to me to be very good. And there are many others. You can find endless tutorials on the internet, and many of them are focused on data analysis or biology or or what have you. Then you can also go on edX or Coursera or one of these things and get a bit of a more formal type of course. So that's also an option. And then last but not least, I have heard that the UP Bioinformatics Center also presents workshops. And in fact, I'm not sure why I'm giving this talk and not one of your own bioinformaticians, but so that's probably also a very good option. So, but then one thing I also want to mention is, so you're going to start learning using a tutorial or whatever, but as soon as possible, try writing your own code, even if it's really something simple, like making a simple graph or doing really something basic. Trying stuff as soon as possible, even after finishing the tutorial. And also if you're doing a tutorial and you come across something that this section is explaining X, Y, and Z, and you have no idea why you would ever want to do that, it's fine to skip that part. So get to doing something useful as soon as possible, and then just go from there and figure things out. That is really how programming works. It is a constant learning experience. You can never get to a point where you don't have to Google things, because you're always learning to do new stuff, and that always requires looking stuff up. So be prepared to always be learning. So it really never stops. So the sooner you can start doing something useful and learning in the process, the better. And then you will definitely come across this website called Stack Overflow. You can find other answers. So questions that you might have the same question, it's already been asked and there's an answer. And if there's something that you can't find the answer nowhere, that's a very good place to also post your own question, and then people will first berate you for doing something awful, but they will then generally give you the answer. So yes, then I just want to talk about some general tips and tricks. The first is use an integrated development environment, also known as an IDE. So two examples are PyCharm and RStudio. PyCharm is, of course, for Python. RStudio is for R. And I would really strongly suggest this. So this is basically a piece of software that integrates everything you need to code. It has a good text editor. It has built-in package management. It can integrate with version control. You can access documentation straight from the IDE. It can support notebooks like Jupyter notebooks, which I will touch on at the end of the talk, and all kinds of other features. It really integrates everything. And in my opinion, this is much easier than using a separate text editor and running your thing in a terminal. And so if you can do this, I guess if you're working on a server or something, it might be different, but this is the route I would go. And these are, well, like I said, RStudio I think is kind of the standard for R. If you're wanting to learn Python, I would strongly recommend PyCharm. I am of the opinion it is definitely the best one, and both of these are free. They have a free version, and I think both of them you can get the full version for free if you are a student or an academic. Another big tip is learn and use version control. So the recommended software here is called Git, and it is also completely free to use, free and open source actually. What version control does, firstly it provides a backup, it allows easy collaboration, and it also allows easy sharing of code. And the way it works, it doesn't just back up a copy of the file, it actually keeps track of every single change that you make to your code. And you can even have different versions of the same code going at the same time, and these are called branches. And then you can also merge them. So you can make a branch to, for example, fix a bug or add a feature, and then seamlessly merge that back. And Git does all the hard work of figuring out how to sort that out if there are conflicts and things. So you will find if you start learning Git, it has a lot of complexity, has a lot of features, and it's very command line based. But there are tools. First of all, you don't have to learn everything. I certainly don't know most of Git, You don't have to learn anything. And there are tools like visual tools that can help you do it, or it can be integrated with your IDE so that you don't have to necessarily memorize all of the necessary commands. But this is very strongly recommended, and I would say essential if you're doing any kind of serious programming. And then the last step, or I think the second to last step, I'm not sure, is to write readable code. Try to write code that is understandable, not only code that is correct and works. And this is for other people, but also for your future self, because you often write some code and then a few months later you have to use it again, and then you can't remember, you cannot remember what you were thinking when you wrote it. So this is quite important. And I have just 3 examples of readability. There are many other things that you can do, and if you go on the internet, you can find very good guides to writing good, understandable code. So one example is use descriptive variable names. So both of these pieces of code do exactly the same thing. So from the computer's perspective, they're the same. But the first one, no one can look at it and know. I mean, you might see temp and think it's a temperature, but actually it's just a temporary variable. However, in the second case, because the variables have sensible names, anyone can look at it and know what's going on there. So give your variables descriptive names and your functions and everything actually. The second tip is use comments. So comments are little pieces of text that the computer ignores that you can use for explanation. But try not to use comments that simply state something that's really obvious. So for example, anyone can see that X is being incremented there. So it's not needed to add a comment, but if you're saying why you're doing it in a comment, that's good. So just keep in mind, you don't want to overuse them if you can just, if it's already in the code. The best is self-explanatory code. And then the last tip that I have is try to use a consistent style. So again, both of these pieces of code are identical from the computer's perspective, but the second one is just, I mean, the first one is just a bit sloppy and visually, and this is not a good way to code. So try to stick to a certain style in terms of where you put your spaces and etc. And Python, I know, has kind of a standard style, and I would guess R as well, and other languages as well. But the most important thing is not necessarily using the standard style, but just using a consistent style. And I think this is just to be aware of that is just important. So the last step I have is don't reinvent the wheel. And this is very important. It's very easy to fall actually into this trap almost. So before you start writing some code, always check, isn't there maybe some package available that does this already, or some code that someone else has written and shared that you can just copy and paste that also will do the thing, or that you can maybe just change. And you'll be surprised. Sometimes you really think you're the first person to come up with a problem, and it isn't. Someone else has already solved it. So don't waste your time. So it's almost always easier to adapt a piece of code, even if it doesn't do exactly what you want. If you can adapt it to your needs, that's almost always easier and quicker than writing your own code from scratch. Sometimes other people write what they call spaghetti code. In that case, it might be easier to read. That's just code that's not understandable. But usually it's better to just take some other code and adapt it. And you will also see that for common things such as statistics and plotting, that kind of thing, there's often more than one package available that kind of does the same thing. So make sure that you kind of look around and look at your options before you choose. Just so if you know, okay, I want to start making plots. Like I know in Python there are more than one package, and they all have strengths and weaknesses. So it's good to look at the options before you start just using a specific package. And then I just have a few more things. So as I've already said, basic Linux terminal knowledge can be very useful. So yeah, especially if you work on a server or a cluster. So for Python, it's very common that people recommend this thing called Anaconda. which is basically a way to download Python, which has a lot of packages already loaded. But it's definitely not essential. Some people kind of make it sound like you're going to have a hard time if you don't use Anaconda. In my experience, I have had more issues with Anaconda than without. So my recommendation, if any of you are actually thinking about starting to use Python, is to start by downloading PyCharm and do your package management inside of PyCharm. You will see in Python, there's this thing called virtual environments. You can do all of that in PyCharm. And in my experience, that works better than Anaconda, because the issue comes when you need a package that is not included in Anaconda. It can get troublesome. So I would actually stay away from that, but just know it isn't essential. It is good for a lot of people, but it's not by no means essential. The other thing that you also might come across is this notebook type systems. So there's something called Jupyter, which you can use with Python and R. And then there's also packages, I mean, software like Mathematica, Maple, SageMath. Those Mathematica and Maple are paid software. SageMath is like a free alternative to those. And they are based on this notebook. It's also called a workspace. I don't know what it's called. In my opinion, so some people might recommend that when you start programming, for example, that you use Jupyter. In my experience, that is not the best environment to write coding. It's a useful way it's useful for education. So if you want to teach someone else to program, it can work well. Or if you want to share your code and put some explanations and kind of text formatting in between your code, because it has these cells and you have formatting in between. That's not, in my experience, the best environment to write coding. So I would just go with an IDE instead of using something like Jupyter. And I just say this because often when you're starting out, especially with Python, which I have some experience with, some people will strongly recommend Jupyter. And in my experience, it's not really needed. So don't worry too much about that kind of thing. Okay, that's my talk. Thank you for listening.
Thank you, Bertus. I think I can agree that it's, well, I hope you agree with me that it's quite helpful. You know, just thinking about this, and, you know, often common sense put out in a nice way is a very good thing to hear, because you often don't think exactly like that. And I think we have a number of new students, especially honor students, in the audience, and it will be quite helpful for them. You know, I am at that age where I think programming, no, I'll ask my son. And he gets very upset with me when I do things over and over, because you can actually quickly do it. But I mean, but for young people, this is something you need to do. You cannot be a biologist without having this. Biology isn't going in that direction, that you're going to work with data. So the sooner you can program, the better for you. And I have two people here in the front going like, yeah. So, but let's quickly hear if there are people that have questions that they want to, or comments.
Thank you, Faunus. Do I have to? Afterwards, okay. I'm very glad that you mentioned version control. So, you know, these websites like github.com and gitlab.org or whatever, they work very well with plain text documents. But most people don't know that a Word document is actually plain text. It's XML. And so it's actually a very good idea to put your thesis or your dissertation or your report under version control. And that solves the problem of having 200 different copies of the same thing in different places. Faunus nods, he knows what it's, yeah. Pre-final, yeah. So put that stuff under version control. I would recommend github.com because it actually gives you a nice view of your Word document. It can render a Word document. You can put it in a private repository. It's like 10 gigs space. You can put some raw data in there if you need to. And then when you're done with your degree, you just share that repository with your supervisor. So instead of having 200 different copies of the same file on 200 different USB drives, just use version control. github.com.
Anybody else that wants to make a comment, ask a question?
Thank you, Bertus, for the talk. Maybe I can make a comment on Jupyter. I agree that it's not useful to use it for your coding, but for us with lab books, I think that is also quite nice. The nice thing from Jupyter side. So for the new students, maybe look into that.
Yeah, that's something I wanted to say in terms of, especially now that people are coding more and more, you need to keep track of what you're doing, because in the end, you need to write a thesis or a dissertation, and you need to explain how these things happen. And I've sometimes seen, that it's one thing if you do experiments and you keep track, but on the computational side, it's just as important to make sure that you actually have a good record of what you're doing, and version control can probably help you with that. But I think that's something that we need to make sure that we do is good, what's the word? Keeping record of what you're doing, especially also if you leave and there's another student taking over. I mean, we often go back to lab books and we see what they do. And a good lab book, you immediately can continue, but bad lab books is useless. You can forget about it. So it's important that even when you do coding, that you actually keep record of why you're doing certain things, especially also when there's people coming, students following up on you, that needs to have that information. I don't know if there are any comments on the, if you can stop that. Let's just see if there are chats. We can look here as well. Here, Bertus van Heerden is asking, what is a good resource to find code that scientists have used for analysis, genome or otherwise?
I just go with Google generally, but yeah, sometimes you do miss stuff. But I think that's probably something that is it's the same kind of I guess it's like finding papers with experimental protocols, or papers can also be useful. I think if someone has made an actual good piece of code, they will probably also be mentioning that in a paper. So and yeah, sometimes people just they don't necessarily share their code, but they might share it if you ask them. So maybe you read a paper and then you just ask the author, maybe can you share it, even if it's not shared already.
Yeah, and one thing about papers is that often what you've done needs to be available to the people.
These days, the journals really kind of want that, yeah.
Okay, any more questions, comments? I think the one thing for biological programs and things, there's, now I can't remember the journal, but it has I want to say nucleotides, but there's once a year or twice a year, there's an issue just on programming that you describe your, who can remember that? Yeah, nucleic acid research. They have a volume every year or twice a year, I'm not exactly sure, where new programs or updates on programs are described. So they give the background, why they're doing it, etc. So I've always found that also to be quite helpful.
So just to add on to this and what Bat said, why we are not presenting it from bioinformatics side. We actually started a thing before COVID called Black Mamba, where we discuss Python problems, but any general problems. And it's like a student based community where we come together once a month or so, and someone presents, and someone, if you have something cool to show or a question to ask, you can. We have a WhatsApp group, and we've got Google Drive and everything. So we want to start that up again, so we'll communicate. This has been a good reason to do so now, that we have to get people from physics to come explain to us.
Well, I think this is a place where we can actually find out that having some physics people in FABI is of use, and where we can start integrating. And those are the things that we're looking for, because biology is also moving in the space of big data and programming, etc. So there's much more integration, maths as well. So we need to work on that. But yes.
Thank you for the talk. It was nice to see a bit of programming and see the logo R at the presentation. So I agree with you with all the programming. It's very important, and more people should start doing some, especially young people. But I think in addition to be scared of learning a new language, they also need to learn to do statistics at the same time.
No, of course.
My question is, in your research for that talk, do you perhaps have any recommendation where new people can go to a website and learn at the same time how to use R or Python applied to biostatistics?
The only thing that I can think of is, I know there's this website called Towards Data Science, which has all kinds of things, tutorials and things on statistics, data science and things. But I think these days, most of the information on the internet on statistics is probably going to be called data science. I think any kind of, there's probably a lot of websites with all kinds of information on data science, which is, I mean, data science is mostly just statistics. So I think that's probably, if you want to learn data science, that's probably going to be the way to go to learn more about statistics and that kind of thing. That and good books. But yeah, so I think there are very good textbooks also on statistics that are not that hard to teach yourself with.
One thing about statistics is, if you don't use it, you lose it.
Yeah, it's like learning a language. If you don't speak it, then you forget. But you know, I'm listening to the discussion here, and you know, there's always reference to Google it and, you know, go on the internet, blah, blah, blah. But people forget we have a fantastic library. And I have taken out two very interesting, well, useful books on R. The one is called R for Biologists, and the other one is R Statistics in R, I think. So don't forget that we have a fantastic library with lots of resources, and you don't have to spend your time looking for stuff.
Another comment?
Just like to ask, how difficult would it be, do you think it would be for someone who really doesn't have any background in any type of coding? I mean, if I find my computer, I feel like I managed to do something on my laptop. So how difficult would it be for someone like me? And who would you recommend I consult if I want to do this, but I really run into trouble and I struggle?
I would say if you really want to learn, anyone can certainly learn it. That was my experience teaching second year students programming. Is the ones who struggle are the ones who aren't really putting effort in, and they just want to get the thing done and get it over with. If you really want to learn, you can really, like I said, start with the tutorial, and these things, they don't assume any knowledge, so they will explain everything. I'm not sure what research group you're with, but I think in FABI, the idea is that there are lots of people who can help, and I know in FABI there are certainly many people who do a lot of coding. So yeah, like I think but this Black Mamba thing is probably would also be a good, if that kind of thing could be useful. But I think you should be able to find someone that can help you within FAPI. So
yeah, and there are a number of YouTube channels and things also, people that are getting towards that. For instance, if you invite micro homework, Pat Schloss, he's involved in some of the programs, and he has a weekly thing that comes out on how to use R for very specific things. We have a video, and you can get a newsletter from him. That's where I got on to Make It Stick. He's discussing how to teach people how to code and things like that. But I think that's it for today. Thank you very much, Bertus. As I say again, it's very nice to have somebody saying, I would like to give a presentation, even if it's your supervisor that does that. But thank you very much. I think it was really worthwhile for everybody just to think about it, and those things, especially at the beginning of a new year, new project.